Howdy folks, Mr. Reed here, and welcome to One More Question. So what we're going to be doing today is we are going to be taking a single graph and an algebraic transformation, and we're going to be drawing a second graph from it. We're going to be doing this for horizontal, vertical stretches and reflections, and we're going to be doing it at a medium level today, which means I'm probably going to mix in a few of these different transformations together. Alright, so if that's what you're looking for, let's get to it. Okay, so what we have over to the side is our graph that we're going to be working with. Above me is the transformation. So that's g of x is equal to negative 1/2 f onto 4x. Now, there is a negative sign involved here, and then there are two, parameters that are not one, or they actually are going to be doing something in this case. So first off, let's start out by drawing attention to what the general algebraic form looks like for these transformations. So that's a onto f onto bx, and so we have the a parameter and the b parameter. As we've said before, if you've seen some of the other videos, the a parameter is going to take care of the vertical stretch and reflections. The b parameter is going to take care of the horizontal stretch and reflections. So in this particular case, we should be able to just read off of our statement what the a value is and what the b value is. So in this particular case, we have an a value of negative 1/2, and we have a b value of 4. And so the question is, what does this stuff actually do? So the negative on the a value is going to be a reflection. I usually view the negative as being kind of separate from the number that's there. You don't have to. You can think about it just as one big thing, but I kind of look at it as the negative is going to be a reflection, and then we are also going to potentially have a stretch that's going along with it. And stretches can be stretches. They can be compressions as well, depending on the value that we have there. So for that a, that is actually a vertical reflection. I'm just going to call it VR, and also a vertical stretch by a factor of 1/2. I'm going to be really brief in the way that I describe it there. We also do not have a horizontal reflection. That is a positive 4 inside of the argument. But that is a horizontal stretch by a factor of the reciprocal of that 4. That 4 could be written as 4 over 1, the reciprocal of which is 1/4. So that is actually a stretch factor of 1/4. Does mean that there's going to be a 4 times compression there. So horizontally, it's going to bring things in together like this. All right, what we can do with this is actually make our mapping notation. So generally, we wrote down in the last video, the mild version, that the mapping notation could be written like this: 1 over bx comma ay. And again, this is just for stretches and reflections. I didn't even say at the time that it was for reflections, but it does work there too. Because all a reflection does is it takes the x value and it flips it over to the other side of the y-axis, which would be the negative value, whether it's negative and it becomes a positive, or it's positive and becomes a negative. So that's what it is generally. For us then, our mapping notation is x comma y is going to map onto the 1 over b is going to be 1/4, and then x, and then negative, 1/2 y. So we're going to be able to take our points, that whatever points we want. I'm going to use again the 4 that I've kind of labeled out there in our particular graph. I'm going to write those down real quick. So that's negative 2 comma 3, as well as negative 1 comma 2. We also have 1 comma 4 and 3 comma 4. All right, now these are all going to map onto new points. So the new points are going to be, following the rule, 1/4 of the x value. So that's going to end up being negative 1/2, as well as, I'm just going to, yeah, that is a value of 3. So negative 1/4, 1/4, and 3/4. So I'll have to be a little bit careful in my spacing. This is going to get crunched a fair bit, and because of that, it's going to, well, we'll see in just a moment. Next up, I have negative 1/2 of the y value. So that's going to be negative 3/2 and negative 1 and -2 and -2. So everything's going to flip vertically, so it's all below the x-axis instead of above the x-axis. So that's why I have negative y values for each and every one of those. Looks great. So now I just have to carefully place these points. So we have -1/2, -3/2. So that's going to be about right here. So halfway in between -1 and 0, and halfway in between -1 and -2 on the y-axis. -1/4. So it's going to be about halfway in between that and the axis, and it's on the -1 position for the y. 1/4 and -2. So somewhere around right there, about the halfway point in between half and 0. And then lastly, 3/4 -2. So it's going to look like about that. Now that's going to be really small. Probably can't see it very well on your screen or wherever you're watching this. But I'm going to play Connect the Dots, and this is going to be the graph that we come up with. So it looks pretty similar to the original graph. From the left to right sort of sense, it is the same orientation. So it has the little spike. The spike is above versus below. So the original graph, we went down and then we went back up. This one's going to go up and then it's going to come back down. And that's because there's been a vertical reflection. So your ups and downs have been switched around. But left to rights haven't, and that makes sense with what we said earlier up above. It also is only half as high as it used to be. So if we went top to bottom, this thing used to be 2 units tall, and now it's only 1 unit tall. And if we go right to left, or left to right, the side to side is 5 units before, and now it goes from going to be half to 3/4 there. So we get 5/4 as being the length of it this way. So we go from 5 to 5/4. That is a 1/4 stretch. So that seems about right. So 5/4 it is. All right, so the idea here, if you're using mapping notation in order to make a second graph using a transformation in a given first graph, we just need to identify what parameters there are there, come up with our mapping notation, get a set of points that we're comfortable with, probably play Connect the Dots and draw your graph. All right, so hopefully that was helpful. If you would like to leave some comments for me, please feel free. Like, subscribe, and as always, take care, folks.